Well, hi guys, it's a long time since I made a video. It's the middle of winter here, it's raining outside, what better thing to do. A few days ago I made a small 50mm sine bar, which was a very easy exercise. I haven't validated the dimension of it yet, but I'll do that shortly. I didn't video this one, so I've decided to make a 75mm sine bar and video the making of. So let's get started. So this one here was made out of a piece of 14mm bar, so it's obviously imperial. This is a piece of key steel, and I used that simply because it was about the right size and it was nicely machined. I've yet to verify this. I have done some quick tests on it, and it is pretty good. I haven't machined the top surface yet. And the top surface needs about 2/1000 of an inch taken off one end, so I'll do that later. So I've decided to make a 75mm one. This one is 50mm between centres. Now 20 years ago, and I've got a date on this, back in March 2000, 19 years ago, 19 and a half years ago, I made this 4-inch sine bar, and I made it because I had one job to do, and that was to make a needle for an aircraft carburetor, a home-built aircraft I might add. And I've only ever used it that once, and I've never used it since, and the main reason being is because when I made this bar it was too wide. It takes up too much space in my vise. So I've got two options. I can either take this to piece, and I don't have any material. I've had a big hunt around. I don't have any material suitable for making a 75mm sine bar. This is too small. I really need something about 16 by 16 or 20mm square. And I don't have any in the workshop. It's the weekend. I can't buy any. So I've got two options. As I say, I can either cut this one up and start again, or I've got a lump of cast iron here which came off a scientific instrument of some sort. It's about the right size, and I could slice it through there and machine it and make it out of this. It is tapered, unfortunately, so there'll be a reasonable amount of machining involved. Or I could put this in the bandsaw and cut a slice off it, about that wide, which would give me the option of a 75mm sine bar and repairing this one, because this one here is it should be 112mm there, and it's about 1/4 millimetre out. So I think I'll take that option. We'll take the two rolls off, take the stop off, slice a piece off in the bandsaw for the 75mm one, and then that gives me the option of returning this one back to use, and I can repair it at the same time. Because having made one and got it right, I've learnt a little bit about accurately machining it and measuring it. When I made this, I didn't have any gauge blocks, and I didn't have good micrometers, and I didn't know how to do it properly. So let's dismantle this one and cut it up. Okay, so I've sliced that off, and so we're going to make the 75mm sine bar out of this piece, and later on I will remachine this and get it more accurate. So that was cut with a bandsaw, that was cut with a bandsaw, and so our reference surface is going to be this one here, which is reasonably flat. So what I'm going to do now is put it in the shaper, using that as my reference surface, and we'll machine that at right angles to that, get that nice and flat. Then we'll put it in the milling machine and re-mill that surface there and mill a new one at 75 millimeters, which will be here. So one of the rolls will go in there and the other one will go into that position there. So let's set this up in the shaper. In fact, actually what I'll do first is I'll just check that on the surface plate and make sure it's reasonably flat, seeing that we are using that as our reference surface on the mill and the shaper, and then we'll machine that. So I'll just check that on the surface plate first. Right, so we've got our workpiece in the shaper. That parallel is tight, and we've got an aluminium rod here on this side, so that if this side is not parallel to that, it doesn't end up canting with the workpiece. And bring our tool back to here, put them in auto advance in gear. Just doing a pass at the moment with a minimum, because I don't know how parallel the top surface is to the bottom surface. So I'm just doing a scratch pass, if you like. I have no idea what this piece of steel is. 20 years ago it could have been anything. It's cutting nicely, so I suspect it might be a bit of very soft mild, not that it matters. For some reason watching a shaper work is lovely compared with a milling machine. I don't know what it is. Is it because they're old-fashioned and 100 years old? There's just something about them. I've had this shaper for a couple of years now, and I really don't know how I did without it. They're so accurate, and they make a lovely finish, quick to set up, and the tools are cheap, and this piece of tool steel will see me out for sure. Not like a rotary milling cutter. Okay, that's not a perfect surface, but it's pretty good. we'll just take another pass and we'll see if we can improve the surface by just taking a 1/1000th deep pass. Okay, right, so I now need to machine the bottom surface. At the moment you notice that we're sitting on one parallel and not the other. So that was the orientation, so we need to put it that way, but before I do that I need to deburr that surface so that it's sitting on the ice nice and snugly. Back short. Right, so that's the surface we've just machined, and we had that surface against the fixture on the vise, so we'll do the same. And we'll just adjust that advance again. There are no marks on the wheel, it's a matter of doing it by eye. And do a tooth-hour cut. So this is the advance mechanism, and the advance is determined by the spacing of the teeth on that gear, which I copied off the original machine. When I bought this machine, all this mechanism was missing, and there was a previous video where I described how I made that. Probably I could put more teeth on that gear there and give us a finer advance if we needed it, but so far it hasn't been necessary. Right, so in theory we've got three faces now that are parallel to each other. So we'll deburr those corners, and then we'll measure it with a micrometer and see how well we did. Right, that's 2044. .2050, so we're 600ths wider at that end than that end. 1.8 1.8 there, 647. Sorry, 2047. 45, 46, 47, 48. Okay. So 300ths of a millimetre from end to end, which is not too bad. And 100th of a millimetre is 0.4 of a thousandth, so it's 1.2 thousandths within 1.2 thousandths of parallel. Now, 20 years ago I machined that and that. I wonder how good it was. So 15, 18, 25. 25, 27, 25, must have been a burr, 25, yep, not too bad. Alright, so now we're going to put this in the mill and we'll mill those two surfaces using that surface as a reference, and then we'll come across on the milling machine and mill a slot, but we'll mill the slot 0.1 of a millimetre short, and then we'll measure it with gauge blocks and then recut it. Now, it'd be nice to machine that and that in the same setting, which I will do by raising it up to there with some bigger parallels. But these ones were made out of a pair of old files, so they're quite hard. Alright, so that's good. It means I'll be able to cut that groove and that one without shifting it in the vise. That's good. Parallels are snug, vise is snug. I'm going to change the milling cutter to an 8mm carbide. We're just taking a clean up pass here to have another look at what was done 20 years ago on the same milling machine, but with a high-speed steel cutter back in those days. Right, so we've done a climb pass across there. The index on the mill is set to 0. And we're going to cut a slot across there at 75 millimeters. But I'm not going to go the full 75, I'm going to go 74.8. Then we'll check it with gauge blocks, put it back in the mill and make the final adjustment, whatever it is, because that means I'm not relying on the lead screw, or I am, but not quite so much. So each revolution is 4 millimeters, so we want to 8 fourths 32 and 2.8. So we want to go 18 revolutions plus 2.8. There's 1, 2, 3, 4, 5, 6, 18 plus 2.8. So there's 1, there's 2, 2, 4, 6, 8. Lock the slides. And I'm just going to check that with a roughly with a ruler. It should be 75 to there, which it is exactly. Right. And I'm going to do this cut full depth so that I end up with this same depth of cut, because that is important, as you'll see later. Being a carbide cutter, it handles it quite nicely.